Now let's look at the formulaic way of calculating these improper integrals. The problem that I'm running into is that I have a function f of x that I'm trying to integrate on the interval, from a to b. However, my antiderivative for this function does not exist at one of those endpoints. This is similar to the idea that I presented in my previous lecture, where I'm integrating out to positive infinity. But it is different for the fact that I'm looking at a finite interval. It's the function that is giving me the problem, not the domain of integration. The way to fix this is similar. The problem endpoint, let's say that the problem endpoint is the lower endpoint. I will integrate from some variable t up to b instead. And then once I have a formula for this integral, I'll take the limit of that antiderivative formula as t approaches a from the right. Now, because I want to use fundamental theorem of calculus when I'm actually calculating that antiderivative, I do want my antiderivative function to be defined at the upper endpoint, b. The same technique will work if it's the upper endpoint that's giving me trouble, right? I can say integrate from a up to b. Maybe my antiderivative does not exist at b, so I'll take an integral from a to t instead. Take the limit as t approaches b from the left. Now, you might have something you're trying to integrate, and you don't have an antiderivative at either endpoint. Let's say that both a and b are giving you trouble. I would fix this by splitting the interval that you're integrating down the middle. Hopefully, in your midpoint, you will have an antiderivative. And then just do the limits on both sides separately. Okay, that was a bit technical. Let's see this process in action. So here, I have the integral from 2 to 5, 1 divided by, oh, excuse me, I have the dx in the wrong spot. Let me fix that. Just a moment. And it looks like I've copied and pasted that the whole way through. So that's what I get for not proofreading my own slides. But there is the integral at least. And while I've been fixing all of my slides, you've probably read the whole thing by now. I'm going to calculate this improper integral by taking the limit as my starting endpoint approaches 2. It's the coordinate a equals 2 that gives me problems. Once I have my dummy variable in place, I can actually calculate this using a u substitution. So this should be old hat now with all the more advanced integration techniques we've been learning about. My u is just equal to x minus 2, and my du is just equal to dx. I just need to swap out my endpoints, and I am good to go. So I have 1 divided by the square root of u. The antiderivative is 2 times the square root of u. I evaluate at 3 and t minus 2, and I get this formula from my fundamental theorem of calculus. I get 2 times the square root of 3 minus 2 times the square root of t minus 2. And as t approaches 2, I know that this second square root is just going to be 0. So the value of this integral is 2 times the square root of 3. All done.